awesome tutor, and today we're going to be looking at the Earth's atmosphere. So, the Earth's early atmosphere, the most prominent gas was actually carbon dioxide, with about 70% of the Earth's atmosphere. And then of course we have like water vapor, and methane, and ammonia. These are all around 10% each. But the Earth's atmosphere now, the most abundant gas is actually nitrogen, with about 78% of the Earth's atmosphere. Then we have oxygen, of course, with about 21%, and then carbon dioxide with about 0.04%, and argon with 0.9%, and of course some other gases. Now the question is, how do we get from here to here? How did most of the carbon dioxide somehow disappear, and how is nitrogen the most prominent gas now, with oxygen as well? Well, first of all, let's look at the water vapor. Now, as the Earth cooled, most of the water vapor actually condensed, and it condensed to form the oceans. But still we have the question, why was there so much carbon dioxide in the Earth's early atmosphere? Because scientists believe that in the first billion years of the Earth's existence, there was intense volcanic activity. And so carbon dioxide was a gas given off by volcanoes. Now what about methane and ammonia? Well, methane and ammonia, they reacted to form some nitrogen. And nitrogen, we know, is a very, very, very unreactive gas. And because it's very unreactive, it did not react with anything, and so it did not disappear. And so it slowly grew to this big amount today. Now, how do we get rid of the carbon dioxide? That's the thing that the exam board loves to ask you about. Okay, the main thing is photosynthesis. And photosynthesis is a process taken by plants, where they take in carbon dioxide and give out oxygen. So most of the carbon dioxide was taken in by plants, and oxygen was given out. And carbon dioxide was also locked up in sedimentary rocks like limestone and fossil fuels, as well as some carbon dioxide dissolving in the oceans. And yeah, okay. So how do we separate gases in the air? By a process called the liquefaction of air. Here we have a fractionating column, and liquefied air is put in at minus 200 degrees Celsius. So the first thing we do is we cool the air until it becomes liquefied, a liquid. But then we have to remove water, and we have to remove carbon dioxide. Why do we have to remove them? Because at these temperatures, they will be solid, because they have frozen. Water freezes at 0 degrees Celsius, whereas carbon dioxide freezes at minus 79 degrees Celsius. So if the temperature is minus 200 degrees Celsius, they will be solid, they'll be frozen, and we have to remove them. Why? Because then they can block pipes. And that will be a problem, won't it? And then we have oxygen, nitrogen, and argon. Now the boiling point of oxygen is actually minus 183 degrees Celsius, with nitrogen being minus 196 degrees Celsius, and argon being minus 186 degrees Celsius. So at these temperatures, they will all be liquid. And at this point, when they're all liquid, what we do is we start to heat the mixture up because they have different boiling points, so they will become gases at different temperatures. So here is where we heat it up. And of course, because nitrogen has a boiling point of minus 196 degrees Celsius, at this temperature it will be gas. And of course, it will rise as bubbles and will come out here as gaseous nitrogen, as a gas. And then of course, oxygen and argon, their boiling points are very similar. And so it's hard to separate them out at this point. And so liquid oxygen and as well as argon come out here as liquids. Because as you see, they're very similar to the minus 185 degrees Celsius, so they tend to stay liquids while the nitrogen rises up because its boiling point is higher. So oxygen and argon come out here, and we usually use a different fractionating column to separate them out later. So the key thing is that they have different boiling points. And that's how we separate out the mixture. These are your key points. If they give you 6 mark on it, just write this down. You'll be fine. Now we're going to look at the uses of these gases. Okay, so you don't necessarily need to know all these uses, but it's useful to have an idea of what they can be used for. Now, nitrogen is very unreactive. You should know this. And so it's useful for making food last longer. You know, you package the food with the nitrogen so it doesn't react with anything and so it lasts longer. We can also use liquid nitrogen to freeze food, and oxygen used in the manufacture of steel and medicine, blah, 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 blah. Here's the important thing, which they might ask you about in your exam. Argon is also inert, which just means unreactive. And so it's used in bulbs a lot. This has been the Awesome Tutor. Bye.